Morning. Today we're going to look at a function at a particular point to see if it has a tangent line. We're going to analyze it for tangent lines at a certain point. The function is f of x equals, it's going to be a piecewise defined function, x squared times the sine of 1 over x if x is not equal to 0, and 0 if x is equal to 0. So the first thing we ask ourselves to see if there's a tangent line at x equals 0 is the function defined at x equals 0? Well, yes, the function is defined at x equals 0. We're told right here that when x equals 0, the function is equal, at the value of f, the y value is 0. So it is defined. So then we need to ask ourselves is, does the limit as h approach 0 of f of x plus h minus f of x, this is the question, of h, does it exist? So what we're going to do is we're going to use this function and we're going to see if this limit exists. So we're going to take the limit as h approaches 0 of f of 0, because x, we're looking at it as x approaches 0. So f of 0 plus h minus f of 0 divided by h. So now we'll just insert our functions. We'll take the limit as h approaches 0. F of 0 plus h, well, 0 plus h is not at 0, so it's a little bit to the right or the left of 0, so we're going to use this function. So we'll say 0 plus h squared times the sine of 1 over 0 plus h minus f of 0. Well, the function is defined at 0, and f of 0 is 0. So minus 0 all over h. So now we'll clean it up a little bit, take the limit, see if it exists. So if the limit is h goes to 0, 0 plus h squared is just h squared. The sine of 1 over 0 plus h is just the sine of 1 over h. And then subtract 0, there's no reason to write it again, over h. So now we're at this point. Now we can do a little bit of canceling. And one of the h's in the numerator goes away, the h in the denominator goes away. No longer have the form 0 over 0. But we do have the form 0 times does not exist. As h approaches 0, 1 over h approaches infinity. As the sine approaches infinity, the limit doesn't exist. It oscillates between -1 and 1. We can use the squeeze theorem. Because of that, we can use the squeeze theorem in order to evaluate this limit. And if you'll remember, the way we do that is we say that on its domain, which is all real numbers except 0 in this case, but the sine of 1 over h is always between 1 and -1. This is a true statement. It's always between 1 and -1. Sometimes it doesn't exist, but it's always between 1 and -1. So then, because we have a true statement, we can multiply through by h in order to do two things. One, to get the function that we're looking at. So we get h, sine of 1 over h is less than or equal to h. And now we take the limit of -h as it goes to 0. Well, that goes to 0. We take the limit as h goes to 0, and that goes to 0. So therefore, by the squeeze theorem, h sine of 1 over h goes to 0. So we can say that the limit as h goes to 0 of f of 0 plus h minus f of 0 over h of this function f of x, that limit exists. In fact, it's 0. To be a little more specific, the slope of the tangent line, therefore the tangent line exists, at x equals 0 of this function. And to be a little more specific, the tangent line has slope of 0, meaning it has a horizontal tangent line at that point.